This is section 2.7, Graphing Techniques. On page 271, we have a summary of vertical and horizontal translations, vertical shrinking and stretching, and y-axis, x-axis reflections. So we're going to take a look at these, keep these down, pause, and write these down, have access to this, and we're going to use these to start, then we're going to talk about even and odd functions as well. Okay, so the first question is, if we know that an ordered pair is on the graph of f of x, let's find an ordered pair on f of x plus 4 plus 8. Now if you look back at those properties, the plus 8 on the outside means we're going to add 8 to the y value. Which is shifting up. And if you look back at those properties, the plus 4 added to the x on the input is a shift left. And if we shifted left 4 and we started at 3, we'd end up at -1 on the x. And then if we started at 7 and we shifted up 8, we'd end up at 15 on the y. Now let's take a look at an absolute value function maybe. So if that's f of x, let's graph negative f of x plus 3. So the absolute value function from the last section we know looks like this. And flip back to those properties. The negative out front gives us a horizontal reflection. So that's multiplying all the y values by -1. And this -3, I'm sorry, that's +3. That +3 is going to shift up. So we take the shape of the graph, we want to shift it up 3, and then we are going to reflect it horizontally. So this is negative f of x plus 3. Okay, let's take a look at this example. Let's find an ordered pair on 3f of x if f of x is the square root of x. So let's choose a value in our domain. X equals 4 is in the domain. So f of 4 equals the square root of 4, which is 2, and that ordered pair would be 4 comma 2. Now, 3 times the function value means we are going to multiply the y by 3. So 3 times f of 4 is 3 times 2, which is 6. And that ordered pair would be 4 comma 6. So we know that 4 comma 6 is on 3, f of x. The definition of an even function is if the original function is equal to f of negative x. And to show that x squared is an even function, we can check the definition. So if the original is the same as the output when you input negative x, so then it's an even function. On a graph, this is y-axis symmetry. So we know that the graph of x squared looks like this. And if we folded x squared vertically, it would be on top of itself. It has y-axis symmetry, and that is a property of an even function. The definition of an odd function is if negative f of x equals f of negative x. So a function can be even, odd, or neither. A function doesn't have to be even or odd. There's a third option of neither. So the first thing we need to do is calculate f of negative x. So let's calculate f of negative x. That's negative x cubed plus negative x, which is negative x cubed minus x if we simplify. And then if we went back to the previous page, check the definition of an even function, the original function is not equal to f of negative x. This means this is not an even function. We can't automatically say it's an odd function. So let's check an odd function using the definition. We've already computed f of negative x, so we need to do negative f of x, which means put a negative in front of everything. So we're going to put a negative in front of the entire function. And after we distribute this negative through, we get negative x cubed minus x. If you look back at the definition of an odd function, this fits the definition of an odd function. And we just showed that by using the definition. So since this f of negative x is equal to this, that's what gives us that negative f of x equals f of negative x. On the graph, odd functions have origin symmetry. So this is the graph of x cubed, which is from our basic graphs from the previous section. So it's an easy function, to show an odd function having origin symmetry, which means it's symmetrical across the diagonal. And one way to kind of think of it, if it had y-axis symmetry, you fold it vertically and it's on top of itself. Origin symmetry means, and you can go back to the definition, negative f of x means negative 1 times all the y values. F of negative x means negative 1 times all the x values. One way to kind of visualize this is if I folded vertically and then I folded horizontally, the chunks of the graph would be on top of themselves. And that's origin symmetry, which is a property of odd functions. Now, if you check the definition of even, you check the definition of odd, and neither of those work, the function you just say is neither even nor odd, but you would have to show it's not even, show it's not odd, and then by default it is neither, meaning it does not have y-axis symmetry and it does not have origin symmetry. So I'm going to talk about relative extreme values here. I think it's something that fits pretty well in 2.6, 2.7. So this is a graph this would be a graph of something that is negative x to the fourth, and let's label some ordered pairs. Let's say that's negative 3, 10. Let's say that this is 1, comma, negative 1. Let's say that this is 6, comma, 5. What I want you guys to be able to do in college algebra is look at the graph and identify the relative maximum. The relative maximum is the tallest hill. So you're walking uphill. At that point, the relative maximum, that's the only point where you're standing on flat ground. You take one more step and you start sliding downhill. So a relative maximum can only occur on a hill. So notice that there are two hills. If you have more than one hill, a turning point, a tall point, then the greater y value is your relative maximum. So this one is not the relative maximum. So the domain of this polynomial is negative infinity to infinity. We disregard the negative infinity and the positive infinity when talking about relative extreme values because we have to have a defined ordered pair on the interval. Negative infinity is definitely not an ordered pair. So using this above, you just rewrite that to say, the y value that is less than all other range values. So down here at this valley is the relative minimum. So on this graph, there's only one valley, so we only have one choice. If there were two, you would choose the least. So you would say the relative max, and I give the ordered pair. I prefer the ordered pair whenever possible. And so even though 6, 5 is a turning point, which is definitely something we need to be aware of, it is not the relative maximum. So one thing to keep in mind is the relative maximum is the function value. So if you were to just say the relative maximum is 10, you are not incorrect. The value at which the relative maximum occurs is the x value. So that would be -3. Of course, the ordered pair gives you both of those pieces of information all in one, all at once. So, and then really, that's the only thing that we need to be able to do is identify that those relative extreme values. So we'll mention an absolute extreme value. So let's take a look at f of x equals the square root of x. Now at 0, 0, square root is defined, but that is an endpoint. There are no values less than 0 in the domain or the range, but 0 is defined. So at 0, 0, we have an absolute minimum. And that's because there are no values less, and we stop on a defined ordered pair. Now if we go this way, the square root of x never turns. There's no turning point to where it goes back to decreasing, and strictly increasing. Which means that there are no turning points. So that graph doesn't turn and go back around. If it did turn, we would have a relative maximum, but it doesn't. So we have no relative extreme values.